Snake was right. Yeah.
So I think that if they did find a feathered dinosaur, which I do not believe they have, if they did, that still would not be proof that dinosaurs turned to birds. Think about it. In an honest court of law, they'd laugh you out of the court.
All right. Well, unfortunately, this has been put through honest courts of law, and every time it's gone in favor of evolution. But also, this is the fossil of Tyrannus. If you look closely at it, you can see the outlines of feathers. Now, I know that there are some creationists who say that no, these are actually collagen fibers, but we can tell the difference. Collagen is structurally very different from stuff like feathers. So we know that this 30-foot animal was covered in simple feathers. Not the extravagant plumage you'll see in modern birds, but very simple feathers.
I do want to make a point for the record.
Wait. Before we move on anywhere,
Yeah.
Donnie, you're claiming it was covered in simple feathers, okay?
Yes.
Flight feathers are designed for flight. They're like a Venetian blind. The shaft is off center so that on the upstroke, they all open to let the air go through. On the downstroke, they all close to trap the air like a Venetian blind. It's an amazing design. We have emus here. They do not have flight feathers anywhere on their body. They have a feather. The shaft is right down the middle with the fuzz on both sides. So I'm not prepared to discuss that one you just mentioned. But again, it's a fossil from the dirt. You don't know it had any children. You don't know that it had different children. You are imagining that. And how can you not see that no fossils are going to count in an honest court of law? Show me an animal today that is changing to something else. We can watch bacteria for thousands of generations in a few years. They still make baby bacteria every time. There are no changes. Well, there are no significant changes accumulating, or it just doesn't happen. That's why I continually say evolution is based on imagination. That's why I love to use SpongeBob.
I wanted to point out to Doc real quick. Alan Fiducia, who is not a young earth creationist by any means,
right,
very strongly anti-young earth creation. He put out a relatively new book. I have it here, Romancing the Birds and Dinosaurs. So this is quite updatable, 2017. And he responds to those arguments. And he points out what you pointed out, Kent, that a lot of these so-called proto-feathers are actually decayed skin fibers. And they did a study, I think it was back in 2005. They've also done follow-ups where they found an excellent match between partially decayed skin from a variety of animal carcasses like sharks, dolphins, ichthyosaurs that look identical to the so-called proto-feathers in Eutyrannus and Sinosauropteryx and these other claimed feathered dinosaurs. And we would all agree that dolphins and sharks don't have feathers. And so, yes, these decayed collagen fibers can fray out depending on the environment. There can be variation in them as well, where they look like, proto feathers, but they're not actually.
Wasn't it certain skin pigments that caused that also? There was a few things, I believe, that caused that illusion of feathers.
Yes. Yeah.
All right. Is it my turn yet?
You know what, Snake? You've been waiting patiently. Jackson, your hand was just raised,
well,
so feel free to. Okay, so we'll go Jackson and then you, Snake. You're going to get lots of time. Don't worry, Snake.
Okay, I'll just
Jackson, go ahead.
Okay. Well, I just want to say Eutyrannus, there were 3 specimens discovered of Eutyrannus, all 3 of which had feathers, and the feather impressions were 8 inches long, which is far longer than any possible collagen fibers could have been. And if that's not good enough, there are impressions of pennaceous feathers on a small dinosaur called Kaihong, which I think if you looked at the skeleton, everyone would agree that looks like a dinosaur. But it also has pennaceous feathers, especially along the tail in the fossil. So that's all I really wanted to say. So just go ahead,
Okay.
Snake.
Kent, go ahead.
No, I get to respond.
Go ahead, Kent, sorry.
Kent, go ahead.
If they found a fossil of a dinosaur that appears to have feathers, or even if it has feathers, that's not proof for evolution. It's a fossil. No animal today is doing this. No animal today is changing to something else. You are imagining that fossil had power to do something that no animal today can do. Maybe there was a line of dinosaurs with feathers and they all went extinct. Could be. I doubt it, but it's okay. for the sake of the argument, let's say that's true. You don't know
Well, I
it's
just saw
changing.
them in
for
my
something
yard.
else.
They're not extinct. They're just flying around out there.
You have flying snakes in your yard?
No. The flying dinosaurs. They're all over the place. They're everywhere.
Oh, birds are dinosaurs, huh?
Yeah.
And I bet you're related to a banana too, aren't you?
By hundreds
Long
of
time
millions of
ago,
years
yeah.
separated. Yeah.
Millions, billions of years
Hundreds of
separated.
millions. That's right.
Okay.
Hundreds of
Okay.
millions. Yeah.
I feel sad that our tax dollars had to pay for that to somebody to teach you that stuff.
Not
What is the
always.
difference? So the difference between Cretaceous limestone and Permian limestone. Almost every one of these imaginary layers contain limestone somewhere within that time frame,
Well,
or
I guess,
sandstone, or shale.
I guess
What's
for
the
the
difference?
composition of the Permian limestone and the Cretaceous limestone, I'm not sure. That's probably a question for Beamsy. But
Yeah,
I think
take it away.
I think
Take it
Snake's
away,
itching to go though.
Okay, go ahead.
If Bimsy wants to answer that real quick, I'd be more than happy to hear his answer because he's the stratigraphist.
It's not a short answer, so just go Snake.
So there is a difference, though.
There is a massive difference, but it takes a lot of explaining. So just take your turn.
Okay. Yeah. So I'm showing on my screen the images from a paper that was a review of Fiducia's claims about the collagen fibers, and a lot of them were actually identified as scratches on the fossils. And this is collagen fibers from an ichthyosaur. They look absolutely nothing like.
What's the name of the paper, Snake, if you don't mind?
Let me see real quick. On the purported presence of fossilized collagen fibers in an ichthyosaur and a theropod dinosaur.
Who's the authors?
It's up on the screen. Smithwick, Mayer, Saita, Benton, Vinther.
Okay, because he does respond. It looked
Okay.
like that paper was from 2013.
That's 2017.
2017. Okay, because I would recommend checking out his newest book that came out after the fact, because he has responded to his critics. And
Okay.
who's right? Well, it might be a matter of, looking at Fiducia's arguments, looking at
we're
those
right,
that have
because-
responded to him.
Okay, so let me get this argument out. And I'm sitting on a few arguments, but I'll try and keep my focus.
Sure.
Is it still showing? Yeah.
Yes.
So on the left here is the collagen fibers from the ichthyosaur, and on the right is just a sampling of fossil feathers. This one's from Sinosauropteryx. Now, they're nothing alike. These are single fiber, just straight lines. There's no branching, and they're crisscrossing each other, whereas the feathers have branching and fraying, of course, similar to feathers, and they have a central rachis, which you can see. If you can see my cursor, I'm circling one of them. That's very clear. The collagen fibers do not have any of these features, so they're very different. And here's just more examples of fossil feathers. They actually fossilize pretty well in many cases. So you can tell this is not collagen fibers, just based on the fact that it's obviously a feather, but also comparing it to actual collagen fibers that don't branch or anything like that. So yes, dinosaurs did have feathers, and we'll get into the argument about how we can tell that birds are in fact a type of dinosaur that branched off from feathered dinosaurs. But we'll just let you sit with that part and let you respond.
Yep. Okay. So Snake, thank you very much. We're going to hand it back to Kent. Kent, I think you're muted on your end. Okay. You're good now, Kent. The floor is yours.
Okay. Again, they are not giving any evidence for evolution. They're showing a fossil feather. I don't believe it, but I'll go again. I'll say, let's say they find a dinosaur with feathers. Does that prove it's transitioning, and therefore all dinosaurs, it transitioned to, and all the birds are part of that same family descended from dinosaurs? No. This is so silly. How can you not see? If you found a feathered dinosaur, so what? That doesn't prove anything's changing. There are no animals today that are slowly changing their scales for feathers. How many animals today have scales? A whole bunch of them. How many are turning to feathers? None. Evolution, science, is what we can observe. It's knowledge gained by observation, testing, demonstration. Show me in a laboratory a scaled creature, and make it turn into feathers. Show me how it happens. And even then, if you could do that, I would argue you're controlling an environment to make it happen. That doesn't mean it happens in nature. I guess really to be science, it'd have to be show me how it happened in nature. You guys, you're not seeing that you're destroying your own argument. There is no evidence for evolution, none. You want to make these family trees and make all the kids be taught this. Go ahead.
Okay, so you don't believe the facts in front of your face. I'm showing you the difference between them, and you kind of just skipped right through that. So let's go through the argument for the fact that they are dinosaurs. This is a creationist method for determining what a kind is, and it's called the multidimensional scaling of barometric distance. And so basically, this is a published paper, and basically, this is only one. I'm only showing one dimension of it. It's actually three-dimensional, but this one's a good angle. I've shown this many times, and basically, what happens is, since the arc is so small and tiny, and the amount of life is just staggeringly varied, and 99% of all species ever found are dead. I don't know about ever found, but maybe that's an estimate. But anyway, most of the animals are dead. Don't know why God would bother making them if he's going to kill most of them. But the point being, you have to fit most animals into a kind to get them onto the ark. And so you have to have animals with macroevolutionary differences having to be related on the ark. So they came up with baromenology. This is one of the methods, but it was abandoned because it proved that birds are dinosaurs, because it showed that the amount of difference between birds and dinosaurs was smaller than the total amount of difference between birds and between the theropod dinosaurs. So birds have all of the distinct.
Actually, Taylor, let's stop there.
Characteristics.
Taylor, let's stop there. I think there's enough points on the table there. We're going to stop there, Taylor. We're going to hand it to Kent now. Go ahead, Kent.
Yeah, he's going to try to sneak in a slap at Noah's Ark and then go on to something else. I'd like to respond.
I didn't sneak it in. It was there.
Snake, look at me. Listen to me. If you don't believe all the animals could fit on Noah's Ark, and you do believe all the animals fit in a dot smaller than a proton, you need to go see a shrink. Do you believe the Big Bang Theory, that everything in the universe, all the stars, not just the animals on the ark, all the stars, everything fit in a dot smaller than a proton? That's what the Big Bang Theory teaches. You're complaining about them not fitting on the ark. For heaven's sake, you think they fit in a dot. What is wrong with you guys?
You're dodging the point. So
I'm dodging the point.
The point is that these animals with macroevolutionary differences between each other have to be able to be related, or else they can't fit on the ark.
Okay, well, let me go back to my point then. I don't know how many kinds of animals were on the ark. I don't care. Okay, but
I know.
But I'm not asking for that to be taught in public schools at taxpayer expense. You want the idea that all the animals fit in a dot taught at taxpayer expense in the public schools. You want the Big Bang Theory taught in schools, don't you? You think that's part of science?
Super dense matter can be smaller than the matter we see right now. That's observable.
Okay, so
it's called a black hole.
Let me translate that.
Actually, that's wrong. You have publicly advocated that the government implement.
Let's keep it on topic. We're having a good show.
He brought it up. He brought up government enforcing religions.
Okay, evidence for evolution. Let's stick to the topic. Go ahead, gentlemen. Continue.
I'm just responding to that.
He said super dense matter. Okay,
Snake, if you're going to keep over talking, we're just going to move on to someone else.
I wasn't over talking. I was being over talking.
Now,
you've been asked to calm down multiple times.
When he mentioned about super dense matter, okay, let me translate that for everybody. He does believe everything fit in a dot. He does believe that. He's trying to hide it. Well, we do believe in super dense matter. Real simple, Snake. Do you believe all the stars, all the planets, all the animals, all the Pacific Oceans, everything came from a dot smaller than a proton, like the textbooks teach? Simple yes or no. Do you believe that?
Yes, all matter can be compressed, and we see that in black holes. And Sam, no, I was being interrupted by Donnie, which is fine if you're the moderator. I'm not trying to call you out, but I was being overtalked. So anyway, yes, matter, super dense matter exists. and is very small. It's called a black hole. Can we move on, or are you going to dodge some more?
Can I address that?
Go
Is that
ahead. I didn't
okay?
dodge it at all. Okay.
Is that okay with you, Kent?
Oh, yeah, please do.
Yeah, so the Bible says that only 2 of each kind had to go on the ark. So if God would have created these dinosaurs from the beginning with a lot of genetic ability to diversify, and they could have diversified quite a bit, but all of those subcategories of the kind didn't have to go on the ark. So it's possible that there were many dinosaurs that didn't survive the flood, and it wouldn't matter. And then when those 2 of that original kind got back on the ark, they might not have diversified in the same way. So I think you're making your argument has a false premise that there should be a representative on the ark of everything that we find in the fossil record, and that's just false. The Bible is really clear, 2 of each kind. So if that original kind paved the way to have all of these different subcategories pre-flood, then we wouldn't have those represented after the flood. That's pretty simple.
Yeah, that's partially a straw man and partially making my point for
that's
me.
actually not a straw man. That's a representation.
Can I talk, or are you going to overtalk me?
Yeah. So I'm gonna hand it back over to Kent if you wanted to continue with him. But
No,
that's
please,
a direct
let him-
answer.
oh, interesting.
Please let him keep talking.
can't
This is
Respond?
hilarious. Go ahead, keep talking. This is
Yeah, you can
hilarious.
respond, sure.
Thank you, Kent.
Okay.
So yeah, that's a straw man, and I'll tell you why. I never said that there has to be a representative for every category. You misunderstood the entire point. The other part of that was in your correction, quote unquote, of me, you were making my point for me. Yes, those representative original kinds that were on the ark diversified so much to the point that every specimen that we found today, which means that there's a large amount of macroevolutionary difference coming from a singular kind. So you're making my point for me, because there's so many species today and in the past that in order to be able to fit on the ark from original kinds, they have to have the amount of kinds on the ark is limited. So things like the horse kind has a huge amount of macroevolutionary distance between it.
Yeah, that's not a problem. We understand that things change. I don't understand why my answer didn't thoroughly address everything that you just reiterated. I've already addressed that. You understand?
There is a lot of built-in ability for morphological adaptation and change. But Snake, I don't see any true anatomical novelty going on in these dinosaur variations. We do see a lot of phenotypic diversity in terms of morphology, but not anatomy, nothing significant there.
I'll explain why it's a problem. Because the amount of change that you accept occurs within a kind is far larger than the amount of change distance between separate kinds.
Well, a lot of that's just going to be your evolutionary assumptions.
No, this can be quantified.
Yeah. So there are kinds such as the dog kind, where we would say something similar to a wolf would give way to all of this abundance, this plethora of different types of dogs. That's a lot of change. That's no problem. That wolf, or whatever that apex animal would have been before flood, would have been able to give way to even more change. It's still not a problem. All we needed was 2 of each kind on the ark, or 7, whatever that number was, and that's all that we need. And so when you say that all of these things wouldn't fit on the ark, that's again one of your evolutionary assumptions that you're forcing on our position, and we just simply reject it. You're just wrong.
That's not what I said. I said that in order to fit them on the ark, they have to change a lot. And the amount of change that occurs within the dog kind is larger than the amount of change that occurs between dinosaurs, Archaeopteryx, and birds, the earliest birds. That's the point that you're missing and completely is going over your head, or what's happening.
Things change. Woo-hoo.
Right. So the amount of change is the question.
Okay, let's Kent, I saw your hand raised, brother. We'll hand it back to you. Go ahead.
Okay, Snake, we all agree there are changes. Are the changes limited by anything?
Yes, they're limited by physics and by the traits of the parent generation.
Okay. Would you agree they have been crossbreeding dogs trying to get smaller dogs to the teacup Chihuahua? I don't know if that's the smallest. We'll say that it is. Okay. Is there a limit? Will they ever get a dog as small as a flea?
No. Is any of that kind of change relevant to what I'm showing on my screen?
Yes, I'm trying to point out that
How?
there are changes within the same kind. 514. Let me get up here. Okay.
Am I proposing changing a dinosaur into a flea? Into a
Yeah.
flea-sized dinosaur?
A chicken.
A chicken is flea-sized?
Yeah, you think that a bacteria went from an elephant and a flea?
Right.
No.
Just to see the
No, I don't.
changes that we observe, there are now 50 varieties of watermelons. Most have been artificially selected as opposed to naturally selected, but they probably had a common ancestor called a watermelon. Is this evidence that watermelon are related to birds?
It's evidence that life can change a lot.
I agree.
So the question is, how much can life change? The amount
Bingo.
of change that you accept is bigger than the amount of change that I'm proposing on screen right now. All that there is a difference between a Microraptor and an Archaeopteryx is a change in like proportion of features that are already present. And so you accept that, actually.
Well, we back to the homology argument. I accept that there are
This is the
similarities.
homology argument.
I accept that there are similarities in many different types of animals. I believe that evidence of a common designer. Why do you reject that premise or conclusion?
You have no way of testing that.
You have no way of testing they got a common ancestor either.
Yes, we do.
You found bones in the dirt. You have no way of testing. You have no
You
way
know-
of testing to see if they had a
Speaking of
common.
bones in the dirt, I have another point to make.
Sorry, do you want to know how we found these bones in the dirt?
Shovel.
It was specifically and only possible because of the theory of evolution. The scientists predicted. What's the best way to test a scientific theory? Is if you make predictions about the natural world, and then those predictions are fruitful. So they predicted that there should be an in-between between birds and theropods because the homology is so strong. So using the theory of evolution, they predicted that there should be a transitional form. The transitional form was found in conjunction with the predictions made by geology, and thus that confirms and tests the theory. That's the best way to test. You can do none of that with the theory that life was created by an intelligent being.
All right, I have something that kind of goes back a little bit.
Just 1 second, Jackson. We're gonna let Kent address that, and then
we'll throw it to Jackson Rowe. I do, before Kent leaves, I still do want to get an answer to Kent's challenges on the geologic column. So we have gone back and forth on this for quite a while. It's been great. Kent, feel free to respond. Then we'll throw it to you, Jackson. And then Snake and Jackson or any other evolutionists on the panel, I'd like to see some answers to the geologic column challenges. Okay, Kent, we'll start with you. Go ahead, brother.
What he is showing is there are variations within the same kind, and there are some pretty bizarre variations, like the Great Dane and the Chihuahua, okay? But they're still obviously dog, and I think the Bible says they can bring forth. So one of the key factors in deciding if they're the same kind is, can they make a baby? Which is why I'm doing my whole Making Babies series, and nobody's answering any of my questions. I should ask every Friday night. I have more tomorrow night. How did this happen? Are we covering the Komodo dragon tomorrow night? You guys are, not strangely, you guys are deliberately avoiding simple questions. Can you give a scientific answer for how this evolved? Not just a generic fairy tale statement. We see varieties of chickens. I agree. They might have had a common ancestor. And there are some bizarre varieties of chickens. There are some bizarre varieties of pumpkins. 111 kinds of pine trees. 12,000 different kinds of grass. 150 species of roses. 60 species of rat, 1,000 species of sharks, 60 species of eagles. Does the fact that there are 60 species of eagles prove in your mind that they're related to sharks? Why on earth would we draw lines on a paper between shark and eagle in the family tree? This isn't science. It is Inside this circle is imagination. There's a family tree of horses, a family tree of eagles, a family tree of potatoes. And that's where it stops. You don't know that they go back to a common ancestor. You're extrapolating way beyond the evidence. I'm sorry. That's not science.
Okay, Jackson, let's hand it over to you. I know there's a
All
point
right.
you wanted to make, and
Yeah,
then
it
let's
kinda
try and
goes-
engage I think the geologic column issue, I think, is a way for us to differentiate between the models, creation and evolution, because Jackson, correct me if I'm wrong, you require the geologic column and all those specific stratigraphic periods and the fossil correlations for common descent. And so, Jackson, feel free to make the point you wanted to or the question you wanted to ask, and then let's kind of engage that topic a little bit.
All right. Well, the point I wanted to make was separate from that. It kind of went back to the feathers argument. So sorry to go backwards, but I just want to show some pictures real quick, if I can share my screen. Let me see. Hang on. Let me remember how to do this. All right, it's showing up.
Yes.
Is that showing up?
Yeah.
Okay. This is
Oh, I think you just accidentally muted yourself, Jackson. Well, I think your computer system might have muted. Okay,
Am I-
looks
am I
like you're
back?
back.
okay.
There you go.
Is it still showing up?
It sounds like you're now using an external mic.
That's weird. Can you hear me at all though?
Yeah,
Yeah.
and it sounds a
Okay.
lot better than before. So I think you might have been using your computer mic. Now you're using
Oh,
your
really?
external mic. So
Well, I'm holding it up to
go
my
ahead.
face. I think that's probably the reason.
Okay, go ahead, Jackson.
Okay. Anyway, this is in Wan Long, and I think this will kind of solve this argument maybe. This is a 7 foot theropod, clearly, but if you look at its arms, you have something extending out, a few feet. And are you telling me these are collagen fibers or are these pennaceous feathers? And I think the answer is obviously these are feathers. So, and if those aren't feathers, that's not clear enough. This is a smaller dinosaur. This is a Microraptor, but those are clearly feathers.
Well,
And if you
one
look
at
at
a
the
time
skull,
here.
of course, you can see pretty. Okay.
Okay.
Sorry, go ahead.
Thank you, Jackson. Kent, go ahead.
You're
stop.
completely missing the obvious. There might have been 6-foot birds, 10-foot birds. Those may be wings. They may be feathers on that creature you found. This is a fossil. You could not prove it had any children. You could not prove it had any children that lived. And you could not prove it had any children that were different. You might have found an animal that's now gone extinct. That's not evidence dinosaurs turned to birds. How can you not see that?
Well, those species are extinct. We know that, but that's really not the point I was making. I was just saying, yes, theropod dinosaurs did have feathers. That's really all I'm showing.
No. Stop. That fossil you found may have had feathers. You don't know that it's a dinosaur. You don't know that it's a theropod dinosaur. Who's classifying this? Who's making the call? Okay. Again,
paleontologists are, I think.
It's dead. It's in the dirt. It's dead. You show me it happening today.
Well, you're not going to like my answer, but have you seen a robin in your yard lately?
Have I seen a robin what?
In your yard lately?
No. Have robins gone extinct? I don't know. Maybe they did.
Well, some bird species have gone extinct, but that's my point is that there's a feathered theropod right there.
The robin in the yard is a feathered theropod.
There you go.
That is your religious belief. That is not science.
Well,
have you seen a potato served? Have you seen a potato served at the restaurant lately?
I have seen that. I have. I had some today, actually.
There's your grandpa. Why did you eat your grandpa?
Well, I'm not sure how it makes sense that it's my grandfather, but he was good.
Great grandfather.
Well,
you believe you're
that
related?
doesn't make sense either. He's alive now. How would he?
Okay, Jackson, do you believe you are related to a potato if you go back billions of generations? Do you believe you were related to
by
the
about
potato?
700 or 800 million years, maybe.
Okay. So yes, you are related distantly to the potato you ate today. Is that what you're saying?
Well, all life on Earth seems to share a common ancestor. So,
Real simple. Yes, you do believe you related to that potato you ate today, right?
and it was delicious.
Good. Thank you, sir. Donnie, it's been 2 hours. I had to wake up before breakfast. Can I quit and you guys keep on? I'm sure you guys
Absolutely,
can handle
Ken. Typically, that's what we do, brother. I appreciate you giving us 2 hours of your time. 2 hours have flown by. We still got 200 people in the audience. They're loving this. So hopefully, Dr. Dino, we can do this again soon.
it. Anytime.
Okay. Thanks for joining
Thank
us,
you.
Kent.
Okay.
Sam and I
Thank
will
you.
stick
Thank
around
you,
for a
Kent.
little bit. I am getting hungry as well. And so I think we'll stick around maybe till the 3-hour mark, and then we'll kind of wrap it up. Sam, you and I have another open mic tomorrow on the
Yes.
Transcendental Trinity for probably
That's
another
right.
3 or 4 hours. So we don't want to
That'll be
burn
good.
ourselves out. But anyways, to the audience, thank you for joining us for the first 2 hours. It's been a ton of fun. Always love these open mics. Since it is the summer months, July and August, typically we do these evolution open mics once a month, but we'll try and sneak another one in there within the next couple weeks. Okay, so anyways, I guess it's just a bit of a free-for-all right now. I know we've got Brian. Brian, good to see you, brother. We got Merritt. We got Nathan. So maybe they had something to add based on some of the points being discussed and engaged. So feel free to introduce yourselves, bring anything up, and we'll kind of go from there.
Hi,
Hey,
I'm
guys.
Nathan.
Sorry,
Can you guys
before you
hear
do
me
that,
okay?
I gotta
Yeah, we
head
can
out,
hear you.
guys. But it was good talking to you guys. I'll be back around.
Good to see
I'll
you,
see you guys
Jackson.
later. Yeah.
Thanks for coming by. Yeah, Nathan, go ahead.
So where
Oh, now we can't hear you anymore. Yeah, you got no sound, bud. You'll have to try to figure it out.
Nathan,
Maybe
your
exit the
sound
studio.
went out. We did hear you at first, but then your sound was raptured.
Unless you know sign language, I don't know what we can do.
Okay, you might want to leave the show and then come back, restart it. That might work. Okay, we'll go to Brian now. And Brian, good to have you, brother. You're doing great stuff over on your channel. Brian, I think you're on mute, so let me unmute you.
Okay. Can you hear me
There
now?
you go. Yes. Yes. How you doing tonight?
I'm doing great. I just had 2 comments in here. I didn't have a question for Kent. The first comment I was going to make was, well, I won't do them in different order than what I was going to do them. But on Jackson, when he showed that image, that was not a theropod dinosaur. It didn't look like a theropod dinosaur at all. A theropod dinosaur was like the T-Rex, the Velociraptor, Carnosaurus, things like that. The dinosaurs with the hollow bones. That was a theropod dinosaur. So I don't know. That looked more like a fossilized bird to me. I don't know what y'all think, but that looked more like a fossilized bird. And they do have fossilized birds in the fossil evidence. But Sam, I really loved your comment on the real issue involved is not the fact that things are changing, not even the amount of change. It's really the kind of change that's being claimed that's the problem. And so we agree that things change over time. Yes. And so I loved your answer on that. I just wanted to let you know that.
Thank you.
Yeah, it was really awesome. I really like this discussion. I just jumped in at the last minute apparently, and everything's y'all been going on for like 2 hours. But I think this is awesome because I just got through doing an interview today, or yesterday technically. It's uploaded today with Dr. Jerry Bergman on my channel. So on the fossil evidence actually. So.
Awesome. But, maybe drop a link to that in the chat, and so we can check it out.
All right. I have to see if I know it's was processing last time. It's already done uploaded. I need to see if it's done processing. It doesn't usually take that long to process. I'll check that out, and if I see it up there, I'll come back and drop a link in the chat. But I have to go for right now because I have to go to work soon. So I'll see everybody later, and I will try to check more of this video out later after it's done recording.
Brian, I appreciate you joining us as always, brother. Keep up the good work, and I look forward to our show together next week.
Thank you. I appreciate it. I'm looking forward to it as well. I'm gonna get ready for it all the rest of this week. All right. Bye.
Take care,
God
brother.
bless.
Okay, so it looks like we've got Nathan Brooks. Looks like you're back with us. Why don't we try your audio?
Check.
Yes.
It's working.
Sounds like
Yeah,
it's working,
sounds
Nathan.
good. Other than I have an echo, I put in some headphones thinking that maybe audio from the laptop was interfering. Okay,
Could be.
great. One
You're a
question.
little low. If you want to up your volume a little bit, that might help.
Excellent. Okay. Just one question for Snake. Where are all of the emergent species? How do you deal with evolutionary paradoxes like extinction?
What's an emergent species, and why is extinction a paradox?
Well, according to you, we're all emergent species. It means a new species. Have you
There are
never heard of
speciation events
evolutionary
all the
paradox?
time. And why is extinction a paradox?
Exactly. It creates a paradox for evolution.
No, why is that a paradox? What's paradoxical about it?
Have you had millions of years for all of these species to come about?
Yeah, so what's paradoxical about some of them going extinct?
Yeah.
Are you
Still having
hearing
a
me?
little bit of an echo. No,
Yeah,
I'm
Nathan,
having an echo. I'm sorry.
your mic. I think you're having audio problems. Honestly.
Big time. Yes. I don't want to interrupt the show either.
I wanted to ask Snake.
What's
So I'm
the
going to bring a topic.
contradiction?
I'm going to
Sorry.
bring a topic into here, and we'll just kind of go back and forth just to make sure we've got a smooth conversation going. And I hear some background noise or breathing, or almost sounds like someone's snoring. I'm not sure where that's coming from, but
Doing bubble gum or something. What is that?
okay. I'll just bring something in there, and maybe we'll discuss a little bit more of the adaptability or diversification of life, basically, that we were talking about earlier. Snake, are you familiar with the paper by I gotta see who's making that noise? Just a sec. Okay, I don't know, maybe it's coming from you, Snake. Maybe there's a bit of an echo. That's fine. Okay, so Feathered Dinosaurs Reconsidered, and it is a creationist technical paper from the International Conference on Creationism. These specific authors, Dr. Matthew McLean, and I think Dr. Marcus Ross was involved in this too a little bit. But anyways, they looked at all these different theropod dinosaurs. They, as creationists, would actually hold to some of these theropod dinosaurs like Sinosauropteryx and Eutyrannus as having true feathers. And they discovered fossil discontinuities within these groups. And so the conclusion of their paper had these theropod dinosaurs not all connected through common descent, but actually existing in separate ancestries. Are you familiar with this paper? And so I guess my point is, whether or not there are feathered dinosaurs, when it comes to the creation versus evolution debate, I would argue that it's agnostic. It's not a way to differentiate the models, mainly because there are some creationists like Dr. Matthew McLean, Dr. Marcus Ross, Todd Wood, so on and so forth. They do hold to the position of feathered dinosaurs, but in their baromenological analyses, they've discovered strong discontinuities and have concluded separate ancestries. Go ahead. What are your thoughts on that?
So I haven't read this, and I don't know what the discontinuities are. The whole paper's down here somewhere. But you shouldn't expect to have the entire fossil record, one. But so these whoever the authors are concluding that there are fossils of dinosaurs with feathers. Right. Yeah. So but their proposal here is that their main point is that birds could not have evolved from land animal ancestors because Genesis clearly states that birds and land animals were created on separate days. That's basically the thrust of their argument, is because Genesis says so.
Right, but in terms of the science, so that they went in with that starting point, that Genesis teaches separate ancestries. And so they predicted discontinuities in the fossil data with these different dinosaurs, some being feathered dinosaurs from their position. And what they found in their analyses were strong discontinuity. So basically, in a nutshell, if you have these fossil groups and you're looking at these different traits in morphology and anatomy, if there are if there's uniformity within that group, then there is, I'm not sure where that echo is coming from. Is that coming from your end, Taylor? It's kind of like a
I'm hearing it too.
It's almost like there's another person in the stream that we can't see.
Yeah.
Unless there's somebody, is there someone maybe at your house with you, Taylor?
No, I'm hearing it coming through the stream. It's like rustling, like someone's like has a paper bag or something.
Yeah, I'm not sure. Let's see.
Yeah, it's weird.
I muted my mic for a little while. I
Yeah,
just turned it back
no,
on.
I do see that everybody's basically muted, and so I don't know necessarily where it's coming from. Oh, praise! How is that coming from you, praise? But yet it says you're on mute.
Another paradox.
So
He's
praise.
just so uber Chad.
Praise, can you unmute and then say something?
It's evolution.
Yeah. So apparently, praise has found a way to be on mute, but then have his sound coming through. So let's see if I remove.
Praise, you're gonna have to chew your bubblegum quieter.
I mean dinner.
Okay.
Okay. All right. Well, with that distraction out of the way, it's weird because he's on mute, but yet I still hear it coming through. And so, okay, yeah, we have these discontinuities in these fossil groups. Basically, we have different species that can be declared, which they do in the paper, as belonging to the same group. But then we have other species that are disconnected due to these traits. And so, anyways, go ahead. But my main point is that this is overall agnostic to the debate of creation versus evolution, because there are some creationists who would hold two feathered dinosaurs. I wouldn't, Sam wouldn't, but for sake of argument, even if there were, we still find strong discontinuities in these fossil species. Go ahead.
Yeah, well, let me just really quick. I think that the word dinosaur itself just adds ambiguity because it has a evolutionary connotation to it. You know, if we don't use that word dinosaur, then we're just talking about kinds that existed in the beginning. And so, you know, was there feathered kinds that existed from the beginning? Sure. It's not a problem. I think when we use that word dinosaur, it's confusing. I mean, we're talking about like a T-Rex now that had feathers on it. Well, I don't think we believe that. So what are we talking about?
How is dinosaur confusing? It's literally just a categorization. It doesn't matter whether they're related to anything or not. Like you can categorize tools as screwdrivers. They're not related, but it's just a suite of diagnostic characteristics. So it's anything that has the diagnostic traits of archosaurs. So basically, it's got that hole in the jaw, like birds have it too. Other skull features, basically generic reptile to sum that up. But also for dinosaurs, reduced fourth and fifth digits on the hand. Foot has 3 main toes, 3 or more vertebrae in the sacrum, an open hip socket joint, as opposed to ours, which are closed. So you can use this definition whether you're assuming evolution or you're assuming creationism or not. It doesn't matter, because we're mammals, whales are mammals, whether even under the creationist paradigm as well.
But if
So
we're talking about a category called mammals, we wouldn't say that humans live in the ocean. So when we're talking about these things that are called dinosaurs, that's what I mean. It kind of gets a little bit confusing.
How is that confusing? No, the definition of mammal doesn't say living in the ocean.
Well, if we're talking about a whale, we would be, right?
No, but not if we're talking about a whale as a mammal. Mammal is not defined as a living in the ocean. Mammal is a larger category than whale.
Right.
I think classification systematics overall is also agnostic. There's a lot of overlap in the creation versus evolution debate. And classification wise, yes, humans, since we are covered in hair, we're endothermic. Virtually all mammals are endothermic, right? And so, we nurse our young. And so there's many different reasons. There's many different traits that make us or put us in the category of a mammal. The question is, are all mammals related? Now, since we do have these groups within groups patterns in the biological world, take your creature, whatever creature it is, pick your mammal, pick your vertebrate, pick your reptile. Let's take a theropod dinosaur, or even take an extant bird. By definition, that creature is going to have to be closer to another group of creatures and further than other groups of creatures, right? As humans, we're going to be more similar to something and less similar to another thing. It turns out we're most similar to chimpanzees. Primates are all most similar to each other. And so we do have these groups within groups patterns in the biological world. Classification is nice, and taxonomists would actually classify humans as haplorhine primates, if I'm not mistaken. The question is, are all okay, go ahead, Taylor.
It actually doesn't matter whether you say they're related or not. It's just like calling hammers hammers. They're not related. These are screwdrivers. We can classify them as hammers and screwdrivers, and we can also classify them as hand tools. And so the same thing, humans are apes, whether they're related or not. And so, and humans are mammals, whether they're related or not. So so it's not really relevant. There is an argument from the nested hierarchy, but that's not necessarily what I'm going through right now.
Well, let me pick, since we've gone.
But I did want to get back to that the morphological distance paper that you brought up about the dinosaur feathers.
Sure. Okay. We'll cover that, and then I wanted to bring up a specific point as well. So go ahead. We'll finish that one up, and then we'll go from there. Snake, floor is yours.
Yeah, because I did have a response. So that paper that I always bring up, it's a greatest hits, shows basically, yes, there is morphological discontinuity between things, and the pattern that we see is that these gaps get filled in constantly as we discover more fossils. But the point here that kind of goes against what you were saying about the discontinuities in the between the feathered dinosaurs is one that's expected whether you're creationist or evolutionist, and two, the gaps between things like theropod dinosaurs and the early birds are smaller than the gaps between actual theropod dinosaurs. So you have T-Rex and Microraptor have bigger differences between them than Microraptor has with some of the early birds. So it's kind of a cherry picking. It seems from my cursory glances at that paper that you cited that they're picking the gaps between certain dinosaurs, but ignoring the much smaller gaps between the dinosaurs and the birds.
So I'll respond a couple of ways. Firstly, I prefer genetics to determine ancestry, right? It's in our genes, it's in our genetics, that I believe is the best way to answer this question of ancestry, because it's our genes and traits that are inherited sperm and egg, not a rock, not a bone. And so I think there's some good from these baromenological analyses through fossil data, but we do know that there oftentimes exists more variation within the same species, as I believe you've pointed out, like Canis domesticus or even Canis lupus, within that one species, two different ones, obviously, domestic dogs and wolves, we have more variation than across species oftentimes. And this is also the case with the fossil record because we have a lot of diversity in fossil groups. But unfortunately, we don't really have the genetics of a lot of these fossils. So we can determine, okay, all of these domestic dogs go back to a common ancestor, or all the, variety of wolves, coyotes, so on and so forth, have their common ancestors. We can determine this primarily through genetics. In the fossil record, you're mostly dealing with more. I know these studies here that baraminologists have done, they're mostly looking at morphology. They're looking at different traits associated with form and structure. But again, I think that's difficult because of the variation that exists within species than across species. So I think genetics is going to be the best way for us to differentiate between the two models, Snake. And that is why I would look to a series of genetic related arguments, basically, to argue for separate ancestry. And so I'd like to at least present one of those, but I did say a lot there. So go ahead. What's your thoughts or opinion on that?
Yeah, and it's not just morphology; it's also their position relative to each other.
Okay.
That's really informative as well. And but the point about how certain species can diversify sometimes a lot more than their cousins that's kind of the point that I've been making most of the night, is that that within observable within our observations and within the species that you accept are related, there is a higher amount of variation than the variation between some of the proposed evolutionary relatives that mainstream science says. So between bird and Archaeopteryx is a very small difference, even though you guys accept much larger differences in horses, in wolves, in mustelids, which are weasels, otters, badgers, things like that. And the same, and if you just compare a series of these things, there's a small difference between our birds and other birds, small difference between early birds and Archaeopteryx, small difference between Archaeopteryx and other feathered small theropod dinosaurs. But when people like Kent go and say, oh, you think a ladybug turned into an Archaeopteryx? Well, why aren't we comparing stepwise backwards from Archaeopteryx down to I've forgotten the name for bugs and lobsters and crabs and stuff. No, I'll remember it, but they can be traced back. But the point is, you need to compare the closest one each step.
Are you talking about crustaceans or arthropods?
The arthropods, yeah.
Okay.
I was thinking archipod. That's not right.
No worries.
Yeah.
I would respond a few ways. Firstly, the separate ancestry model would understand that some groups, like for example, your felids, there's more DNA differences. There's a greater degree of genetic difference within your felid. So whether you're looking at your house cats, lions, tigers, jaguars, cheetahs, and so on, there's greater genetic difference within that family, who we as creationists would argue belongs to one created kind, than we find in humans and chimpanzees.
Yep.
But yet we as separate ancestry proponents, we would argue that humans and chimpanzees aren't related. And so the question is why? And so we understand that, yes, oftentimes that is the case, what you're saying, which is why I think we need to look at discontinuities. But again, discontinuities in fossil groups, I believe, can be deceiving because of that diversity problem. But if we look to the genetic data today, for example, one that I like to look to, simple to understand for the audience and good to engage with the critic, is, and I've got a diagram here, and so I believe this is a way for us to discriminate between the models. And we have Y chromosome data for great ape species. So here we got humans, chimpanzees, bonobos, gorillas, and orangutans, 2 different species of orangutan. The Y chromosome is uniparentally inherited DNA, right? It's only passed down on the father's side. So it's paternally inherited. Because it's uniparentally inherited, it's also non-recombining. So there's no recombination that occurs from generation to generation. And so it's basically passed down unbroken. And so every time you get a mutation, you get more branching on a Y chromosome phylogenetic tree. But the point is, it should be relatively more stable. All humans, we have a Y chromosome that's the same, nearly identical, very low uniformity, or it's very uniform. And I would argue we can trace Y chromosomes back to a single Y chromosomal ancestor. But the problem is when we compare the chimpanzee and chimpanzee Y and human Y, we've actually discovered, and according to the common descent model, humans and chimpanzees are related through common ancestry, and chimpanzees are our closest cousin. But Y, if you look at this diagram, notice the human Y versus the chimpanzee Y. They're nothing alike. And when you compare overall architecture, gene content, and size differences, the chimpanzee and human Y chromosomes are only about 35% the same. As a matter of fact, if you look at the human Y and the gorilla Y, they are more similar to each other than either are to the chimpanzee Y. And so I would argue that that is a break in the nested hierarchical pattern that evolutionists oftentimes speak of. Here's the last point I want to make, and then take your time, Snake. So here in a 2020 paper, they've pointed out that their Y chromosomes differ enormously in size and gene content. They argue the chimpanzee Y is only half the size of the human Y. So right off the bat, you're starting with 50%. The percentage of chimpanzee or of gene families shared by, so the gene families are totally different. They say puzzlingly, in terms of shared genes and overall architecture, the human Y is more similar to the gorilla Y, just as I said, than to the chimpanzee Y, even though human and chimpanzee have a more recent common ancestor. And so I would argue this data is far more consistent with the separate ancestry model that says humans are not related to any other form of life, including the chimpanzees. And so this is the kind of discontinuity in genetics that I think we should be looking at rather than fossil continuities or discontinuities. I said a lot there, but it is one topic, and I'd be curious as to your thoughts, Snake.
Yeah, so these that's not actually unexpected, because if you understand that humans did not evolve from chimps and humans and gorillas diverged from each other from some common ancestor. So the common ancestor would have traits that is kind of a synthesis of all those. So what probably happened was that chimp's Y chromosome mutated in a direction that gorilla and human Y chromosome did not. And that's not unexpected at all.
So I would agree. Yeah, according to the evolutionary model, your humans and chimpanzees, one did not come from the other. They share relationship. They have a common ancestor. So you can see here humans and chimpanzees. Chimpanzees and bonobos go back to a common ancestor about 2 million years ago. Humans and chimpanzees go back to a common ancestor about 6 million years ago. And then eventually you get the connection with the gorillas. And so since that split between humans and chimpanzees, basically the chimpanzee lineage has had to change dramatically in that 6 million years. But why in, let's say, 200,000 years, according to the out of Africa evolutionary model, humans have been changing, experiencing mutations, moving to different parts of the globe? Why is there such uniformity in the Y chromosome? Every single human male Y chromosome is still 99.999% the same. Hasn't changed at all, really. There's also no diverging people groups on the globe in terms of the Y chromosome. Very uniform. But then you bring in the chimpanzee, our closest cousin, and then we share a common ancestor apparently with the chimpanzees according to the evolutionary model. It's nothing alike. I mean, to me, this data fits my separate ancestry predictions, because I would argue you have humans, they're their own created kind. Chimpanzees and bonobos, they go back to their own created kind. Gorillas exist as its own created kind. And then your orangutans go back to an orangutan archetype. And the Y chromosome data fits that nicely. And so, Snake, you would have to show us how the Y chromosome can change that dramatically in 6 million years within the chimpanzee lineage. Go ahead.
Well, usually the Y chromosome is one of the fastest mutating chromosomes in lots of different organisms. But I don't have anything about how quickly the mutation rate diverged. But it's not unexpected. Like, it's not preclusionary that chimp Y chromosome has diverged significantly. You'd have to quantify that. I don't have data on that right now.
Well, I appreciate those points. I would argue that it is preclusionary. They did not predict the massive differences in Y chromosome. This is from the 2010, I think it is, paper, the original paper on how divergent in structure and gene content the Y chromosomes are. And they say all throughout the paper, when it comes to the gene content, the size differences, the architecture, they use words like, as we can see here, surprisingly, more than 30% of the chimpanzee MSY has sequences no homologous alignable counterpart with the MSY. And so they frequently talk about how surprised they are. It was not predicted. They actually said directly in the paper, this was a shock because this is what was expected in terms of DNA differences between chicken autosomes and human autosomes, which, even according to the evolutionary model, chickens and humans share a very distant common ancestor. And even as late as 2020, in this feedback article, they pointed to a couple possible reasons why we have these massive differences. But they point out that these hypotheses, I've highlighted it here in orange, they need to be evaluated in subsequent studies. And so I find, given the fact that these hypotheses are not yet tested, it's not science, and it's just a story so far, because there hasn't been any mathematical models presented. Again, this data wasn't predicted, and therefore the most parsimonious explanation that obviously the authors of these papers won't conclude is that there exists separate ancestries. Humans and chimpanzees aren't related, as evidenced by the massive dissimilarity in Y chromosomes. Go ahead, take your time.
Can I jump in?
So I had a couple of responses.
Yeah, take your time, no rush.
I'll try to be quick so someone else can get in there. So I don't think creationists specifically predicted the Y would be different between chimps specifically and humans. Just a general prediction of, well, they hope that there is some sort of gap. But the Y chromosome is mostly junk anyway. You don't need one to survive. They're called females of the species. So basically what the Y chromosome is, mostly what it does is just introduce testosterone. So it doesn't actually have to be very complicated. It doesn't have to have a lot of content in it. It can change a lot, which is why it is one of the most quickly evolving of the chromosomes, because you can mess with it. Mutations don't have much of an effect. But so, I mean, I also don't have any quantification on how fast the chimp chromosome is evolving, although I made a quick Google. Maybe we can circle back to that. But I also didn't see any quantification or calculations on your end of why that's actually preclusionary, or that it couldn't have changed that fast, or as fast as it needed to. So I don't understand why that's preclusionary.
Okay, I guess a few points. I would argue that the Y chromosome is entirely necessary. I mean, it's the genetic feature that makes a man a man. I think it's an evolutionary assumption to argue that it's mostly junk. But if it was mostly junk, then why is every single male Y chromosome in terms of humans the same? Because you're saying that the mutation rate is faster in the Y chromosome than in other genetic parts, let's say autosomal DNA or mitochondrial DNA. And the Y chromosome, it does mutate fast. It mutates about 3 per generation. Some say 1, let's say anywhere between 1 and 3. And the evolutionists would argue that humans experienced a bottleneck in Africa, and people left Africa roughly 100 to 200,000 years ago. And so they put Y chromosome atom about 200,000 years ago. And so let's say men, people in general, are spreading to all parts of the globe. A lot of people groups are becoming geographically isolated from each other. And so they would be accumulating their own independent mutations in the Y chromosome. And so if that were happening for 200,000 years, then we shouldn't find such uniformity in the Y chromosome. Yes, the Y chromosome mutates fast. People groups, according to the evolutionist model, have been separated for a couple 100,000 years since out of Africa. So why do we still find low genetic variation in human Y chromosomes? If that were the case, there should be a lot more diversity, but there should be a lot more divergence in people groups worldwide. We don't find that to be the case. And then again, we bring in the chimpanzees, and it's only about 35% the same. And I would say it's the evolutionist who has the burden of proof, since you guys are the ones saying that we're related to chimpanzees, to test your various reasons or hypotheses as to why the Y chromosomes are so different. So I've heard they're different because of sperm competition, faster mutation rates. I've heard they're different because faster rates of gene conversion. Okay, but we need those to be tested, not just asserted, but tested for them to be considered science. Go ahead.
Yeah, so unless you have actual numerical data that indicates that chimps could not have diverged that much, it's really not a problem for the evolution side, and there's many more points other than just the Y chromosome. I mean, one of the things about the Y chromosome is that it's full of a lot of tandem repeats. So those aren't really functional parts of it. It's the smallest chromosome by far. And again, it's not necessary for a human to live at all. You can get most of the necessary information that we have is in the X chromosome. And actually, you can have a damaged Y chromosome and still be alive. They're just androgen insensitive women, actually, and they can actually be fertile women even though they have XY chromosomes. So again, I think that you need to provide numerical data on that chimps can't mutate that fast. And of course, it would be great on our end to show that, of course, yes, it can. But if you're making the claim, obviously, if I'm making the claim that it can, I need to provide that data. But if you're making the claim that it can't, you need to provide that data too.
I would argue, and then Sam, I'll hand it to you in one second. I just wanted to say, in terms of the tandem repeats exist in large stretches in the entire biological world. I would argue that they're there for functional reasons as well. The Y chromosome is not that big. I think it's 59 million nucleotides long. We could look at the exact number. The mitochondrial DNA is tiny. It's only like 16,000. And so I would argue that, yeah, everything for the most part of that Y chromosome has to be there for a reason. It's not that big, and yet it has a pretty big role in determining the male, basically.
And I forgot to kind of respond to your question too. So there's not much diversity, relatively speaking, today among humans. But if you compare older human species or older human samples to today, it's a much larger difference.
Here's the last question I want to ask, and then Sam, over to you. I appreciate the back and forth on this, Snake. Is it possible that the reason why the Y chromosomes between humans and chimpanzees are so massively different? Again, only about 35% the same. The Y chromosomes are only half the size. Is it possible that the reason is because humans and chimpanzees are not related?
Possible. Anything's possible. I think that it's highly unlikely given all the other evidence that we have. Of course, just as an isolated feature, yeah, anything's possible.
Okay. And
Is
as
it possible that it could be due to accelerated substitution rates?
Well, again, accelerated substitution rates, sperm competition, because we know chimpanzees exist in polygamous relationships. The male does all sorts of weird things in its mating, because there is quite a bit of diversity in Y chromosomes within chimpanzees. Still nothing compared to chimpanzees and humans. Faster rates of gene conversion, whatever the explanations, I've read them all in the papers, but they still say, at least as of 2020, that these hypotheses go untested. So I'm just waiting for them to be tested. I am waiting for some mathematical modeling in terms of how these changes, these rearrangements, these massive losses could have occurred in the 6 million years since the split. And so, we'll see. Once that comes about, we'll look at that data and we'll see if it's sound. Snake, feel free to respond to anything there, and then we'll toss it to Sam.
Yeah, I'm looking at a dynamic evolution of great ape Y chromosomes, published in 2020. They're looking at the repeats. They have intrachromosomal contacts, which and that there's a lot of multi-copy genes, and kind of what you alluded to was also there was a high sperm competition. So basically what that would mean is that there's high differences between different sperm have different mutations on the Y, and so there would be higher variation between chimps and bonobos, which are also a type of chimp, then experienced between sperm competition with humans. And so with that factor and with other factors, just like the basic structure of the chimp chromosomes, the authors of this paper concluded that chimps experienced a accelerated substitution rates. And I'm looking for the actual numerical rate.
If I could, yeah, that paper is the one that I screen shared, where they talk about how it's half the size, big surprise, nothing alike. In the commentary article associated with that paper, that's where they say on screen, they say that these reasons that you've provided, they need to be evaluated in subsequent studies.
Mm-hmm.
And so that's basically my point. Yeah, the sperm competition, faster rates of gene substitution, these possible reasons for the massive discrepancy in Y chromosomes needs to be evaluated. We still need some modeling. We need some math. We need some more evidence to back up those stories at this point, is what I would say they are.
I mean, what that would mean basically is like, here's a bunch of possible ones. We don't know if one is the main contributing factor or whether they're equally contributing factors, or whether one is just a non-issue and the others are important. The other one would be elevated gene death rates. So it seems like they're losing a lot more genes than we are due to some of these things. And so they know that they are losing these genes at a higher rate. But the question is why? And these are possibilities, and yeah, we'd want to know which one is the main one or what.
So did you just acknowledge like a genomic degradation?
Not in the sense that you're talking about.
Losing genes? Isn't that going the wrong way?
Gene loss is not genetic entropy.
It's not. What is it?
It's gene loss. Genetic entropy is inevitable genetic degradation throughout the entire genome towards non-functionality, no matter what. That's not the
what
same
happens when
as
you lose?
losing genes.
What happens when you lose too many genes? Are you going to have problems?
Yeah, which is why there's also new genes that come about.
So that would be a form of genetic decay.
Yes, but not in the
Well-
sense that you mean, because it's not genetic
Well,
entropy.
no, I mean it is in the sense that
It's not.
you've acknowledged a gene loss, and gene loss is genetic decay. And
That's not a
if
scientific
you lose
term.
enough
Matthias.
genes,
No.
it's going to be catastrophic. And so is there which that wasn't the question. The question I was, let me back up. And I know you want to touch on that. That's fine. But I was going to ask you, Donnie, to elaborate, because it seems like I've heard you ask this question that you've posed to Snake. Yet, again, I know this isn't the first time this question's been posed. I've been hearing you ask this question for years now. And so when an element is extremely fast mutating, yet we don't see a lot of mutations on it, I don't know how you can interpret that any other way than being young. I mean, it's not a complicated argument. I definitely can't go as deep as you guys have. I would say that I'm a layperson, but I understand the argument. It's really simple. I don't understand why you didn't get it. So maybe,
Right. I would argue that, and you nailed it there, Sam. And obviously, Taylor, we'll throw it back to you after, to be fair. If we have low variation, for example, here's a Y chromosome phylogenetic tree. Okay. This is a representation of worldwide Y chromosome data. Specifically, Dr. Rob Carter made this tree using worldwide Y chromosomal data. And so there's actually very low variation on this tree. Very few differences. We actually find variable mutation rates as well, because we find in certain groups, we have differing size branches, showing that it is possible, and it has occurred, that some people in the same amount of time are picking up more mutations than their cousins. And so the mutation rate is variable, but overall what they've discovered, and Taylor pointed this out earlier, the Y chromosome overall mutates quite fast, both 3 mutations per generation. And so with a fast mutation rate, but incredibly low variation. And what I mean by that is every single male Y chromosome, whether you take Y chromosomes from Africa, from Europe, from North America, South America, Australia, they're the same. They're nearly identical. There's no Y chromosome group somewhere in the globe in an isolated population that are vastly different. You'd expect that. You'd expect that to be the case, though, if deep time evolution were true. We don't find that. And so with a fast mutation rate but low variation, the best explanation for that is that the Y chromosome is young. And that way it can mutate fast but still maintain uniformity. But if the Y chromosome is old and it mutates fast, there shouldn't be such uniformity. There should be more diversity and also more divergence in isolated people groups around the globe. Does that make sense? And feel free to respond.
Yeah, no, I don't think we'd expect humans would have different Y chromosomes that different. We would expect them to have much different Y chromosomes to other apes, which we do. And a lot of these mutations are in these huge tandem repeats that are just, it's in the name. It's repeated over and over and over and over again. And these, essentially, most of them don't code for any proteins, so it doesn't change much to have mutations in them. So Sam, to address your point, the ocean is losing water, but it's also gaining more water than it's losing.
Yeah,
so that's
Meg.
a problem.
And the difference
just
in the
real quick, I'm going to wrap up.
Well, you're changing the subject
real quick.
I wanted to stay on that really quick. So the question wasn't whether or not there is a loss of function or whatever with these mutations. It's the fact that it's mutating fast. That's the argument. I just feel like you
Yeah.
hand waved it away, but that's all right.
So
I don't think there's an answer
it's
for
not
it.
mutating quick enough for us to modern humans to all have completely different Y chromosomes. But your point about
It's a
genetic
fast
entropy,
mutating element, right?
yeah, but it's not that fast. You're just hearing the word fast and just without any numerical calculation, and you're just saying, well, if it's fast, then it must be as different as I want it to be.
Well, actually, the calculations are going to be either the pedigree, the observable rate, or they're going to be based on your evolutionary. I believe it's a phylogenetic rate, which is just an assumed rate because it is fast. I think that the problem is that it is acknowledged that it is a problem. You're just hand waving it away. But
no, I'm saying
it's something that's been acknowledged, and you guys have created a mutation rate to kind of sweep it under the rug.
I'm saying you need an actual numerical rate instead of just saying it's fast, therefore it's too fast. Because that's all
that's
you
what I
said
just
is
said.
the word fast. That's not scientific or numerical at all.
Well, I
other point
used
is
a
about
phylogenetic rate and a pedigree rate as an example. You know what those are, right?
yeah. So cite the rate
Are
that's
those
too
scientific
fast
terms,
for what
Snake?
we observe.
Are those scientific terms?
So cite, yeah, I've already said yes.
Okay.
So cite
what's the
the rate.
difference
So
between
cite
those
the
two?
rate that's too fast.
What's the difference between a phylogenetic and a pedigree rate?
That's not the point. The point
That is the point. That
no, it's
actually
not.
is the point.
You're
Because
distracting
you're the
from
one
the
who wanted
point
the
because
numbers, and I'm
you just
bringing this
want to
up.
use. We have to
You
stay
don't
on
wanna-
point here.
You don't want to answer it?
We have to stay on point here. You
This
need
is
to
the point.
provide
The point is
numerical
you have a
data.
phylogenetic rate and a pedigree rate, and I'm asking you what the difference is between those two.
Nope,
And
that's not the point at all.
would
The
you
point
need
is what the rate is.
phylogenetic rate at all? Why would you need that? Why don't you just accept the pedigree rate, the observable rate? That is the entire point. Why are you dodging the point?
No, you're dodging the point because I asked you,
You don't want to
show
answer
me
it? That's fine.
show me the rate. Yeah, you don't want to answer, that's fine.
Yeah,
Show
Johnny,
you don't want to give me the rate.
Slides on
You don't want to let me finish. You don't want to let me
guys,
address your
let's make sure
points.
we're doing equal time. So I appreciate the passion.
Yeah, I would like equal
Snake,
time.
finish your thoughts, then Sam, my brother, will throw it back to you.
Fair.
Yeah, go ahead.
Yeah. So you have pivoted away from the point which I asked you for, a rate that shows that it's going too fast. You just keep saying it's too fast. Show me that rate.
Yeah,
and I
Donnie
did want to
showed
address
you
your other
that
thing
rate.
about genetic entropy, but it seems that we've flown far off track.
So can I answer that now? You want to see the rate? So Donnie showed you that rate. Those were the charts that he showed you. And I brought up the acknowledgement of this word that you're calling fast, that we're both agreeing is fast, and that would be the pedigree mutation rate. And you understand what that is. So I don't know why you're saying that. Well, you're using a word fast and it's unscientific, but Donnie showed you a charts and I referred you to the rate. So I feel like you're being disingenuous there, but that's fine.
Because the question is how fast.
You understand what those rates are, right?
The question is how fast, and you haven't given any
fundamental
answer.
theorem of natural selection with mutations.
Well, it's about 3. So in the Y chromosome, it's about 3 per generation. In the mitochondrial DNA, it's about 0.5 per generation. And in autosomal nuclear DNA, it's about 100 new mutations per person per generation. So for genetic entropy, it would apply to the entire genome, of course, but mostly to autosomal nuclear DNA, where we have 100 new mutations per person per generation accumulating in populations. But with the Y chromosome, or we could focus on the mitochondrial DNA, it's very similar. If we have a fast mutation rate, we know it's fast because 3 per generation, but then only being separated by a few DNA differences worldwide between any two people. Well, that means it doesn't take a long time to accumulate those differences. And so I can demonstrate this through specifically the mitochondrial DNA. I think it's the least messy, put it that way. And so Snake, feel free to respond, or whoever. This one's a mitochondrial DNA phylogenetic tree of women worldwide. Okay, if you look at the HVR haplogroup, most common in Europe, we have differing size branches. And these branches all go back to a common ancestor, but some branches you'll notice differ in size, telling us that some people are picking up more mutations than their cousins in the same amount of time. That tells us the mutation rate. I'm hearing some feedback. The mutation rate is variable, but nonetheless, it is overall it's about 0.5 per generation, give or take, depending on the people group or inbreeding, isolation, things like this that could affect the mutation rate. There's only about 25. There's a paper in the secular literature where you can actually look at the Eve consensus sequence and you can see how many nucleotides on average separate people, any two people. It's about 25, give or take a couple. And so if you have a mutation rate of 0.5 per generation, Snake, how long does it take to generate 25 differences? Not very long. A couple hundred generations max. That's biblical time. But you want to take Eve back, what, 100, 200,000 years? Well, why so few DNA differences? Why not more is the question. Go ahead.
Because we're
But Donnie-
also forgetting to factor in the fixation rate as well, which is different than mutation rate. That's a big problem. So you need to answer the question, how fast is too much for the observed distance? And this has to be numerical, Sam, not just it's fast, therefore it's too fast.
Donnie just gave you those
so
numbers.
for mitochondria. And
Did you deal with
but
those?
yeah, we also have to factor in the fixation rate.
Okay,
But I
well,
feel
I
like
want to answer the fixation rate. Chris Roop and I, we put out a very detailed article, technical article on this issue, genetic drift, fixation, substitution, so on and so forth. Basic population genetics tells us that the per generation mutation rate over time equals the fixation rate. So if the per generation rate is 0.5 per generation, over time, that is also the fixation rate. And so looking to the fixation rate over the per generation rate doesn't help the evolutionists at all. So here in this paper, yeah, we do see that the pedigree rate, the empirical rate, as in you can take grandmother, mother, and daughter, and you can see how many differences separate them, and you can come up with a mutation rate. And it's fast, firstly, because evolutionists agree it's fast. Notice in this paper from 2022, estimates of the mutation rate with a non-phylogenetic approach, namely pedigree analysis, that's what I'm talking about here when you get grandmothers, mothers, daughters, are reported to be approximately 10-fold higher than phylogenetically derived rates. There's other papers that talk about how this is a rate that's much faster than ever predicted or expected. But the point is, when you manifest DNA diversity worldwide on a phylogenetic tree, you have very low variation. On average, you have just about 25 separating any two people. And so with a mutation rate that's 0.5 per generation, again, over time, your per generation rate equals a fixation rate. This is population genetics 101. You don't have much time to explain these DNA differences. You've got a couple hundred generations, and you still can account for bottlenecks in purifying selection because it doesn't take long to rack up 25 differences. And so again, you can still account for purifying selection. You can account for bottlenecks, genetic drift, so on and so forth. And so that's how we know it's too fast for deep time evolution. It's not too fast for the young Earth creation model because what we're looking at is a young Earth creation time frame. Go ahead.
So it's actually 0.05 mutations per site per million years in this paper that you cited.
Which paper?
Pedigree-derived mutation rate across the entire mitochondrial genome of the Norfolk Island population.
There's a paper where they've looked at the D loop, the control region of the mitochondrial DNA, and based on extrapolation, they concluded that the mitochondrial mutation rate is about 0.5 per generation. Other papers have concluded it's 0.1, 0.2. And so you can even go with a lower number and it's still easily explainable in light of the genetic variation. I think that the strongest data in light of the D loop data is about 0.5. Most people don't argue against that. But if you wanted to go with a lower, it's still, it's nothing to explain the roughly 25 differences that separate any two people. Take your time and respond. I want to find the Eve consensus sequence paper to show you what I mean. Go ahead, take your time.
Yeah, so that mutation rate and the fixation rate are different in this paper. And you were saying that the fixation rate is the same as the mutation rate? Because that doesn't make sense, because wouldn't that mean that every mutation that's currently occurring right now is getting fixed?
Over deep time, you have, I can pull up the technical article and I cite a popular population genetics textbook. Basically, in a population that's fairly large, over enough time, you have, through genetic drift, you have a lot of mutations entering the population. Many are not being fixed. Some are being lost, but many are reaching fixation over deep time. And so that's why they argue that the per generation rate equals the fixation rate. And I can find you that quote. I just got to pull up my...
Yeah, I need to look at that paper, because that's actually impossible for every mutation that occurs to become fixed in the population.
Over time, because remember,
because they're occupying the same gene.
Over deep time, you're fixed, because yes, mutations are lost, mutations drift, and they don't all reach fixation. But because you have so many mutations entering the population over enough time, that per generation rate will equal a fixation rate. It sounds counterintuitive, but it is basic population genetics. For us as a creationist, yes, we don't have deep time, right, Snake? But at the flood, we have a bottleneck of 8 people. And then at the Tower of Babel, we have a bottleneck of about 10,000 people. And so during that time period, we would have rapid fixation of new mutations, because we would have a fast mutation rate acting upon a small population. And so you'd have a lot of mutations manifesting and then becoming fixed. And then eventually people spread out to all parts of the globe. And now fixation rates are slower because the population is growing and people are spread out. But I would say during that first 500 years or so after the flood, you'd have the majority of these mutations becoming fixed. And then after the Tower of Babel dispersal, it changes from there. Go ahead.
Yeah, that does. So I'm gonna have to. I have to head out in like a couple minutes, but just send me that. I'll see what you're interpreting there.
Yeah, how about some equal time here?
Yeah, actually, if I could, but before you leave, here's the article I put together. Me and Chris wrote. We had Dr. John Sanford peer review it.
But what were you citing about the fixation rate being the same as the mutation rate?
So right here from Douglas Futuyima, he this evolution textbook, he says the neutral theory of molecular evolution holds that although a small minority of mutations in DNA or protein sequences are advantageous and are fixed by natural selection, and although many mutations are disadvantageous and are eliminated by natural selection, the great majority of those mutations that are fixed are effectively neutral with respect to fitness and are fixed by genetic drift. But that's not the specific quote I'm looking for. Go ahead, George.
That's just I have that paper, I think. That's where he compares the evolution rates when you add in beneficial mutations.
Right. Yeah, he's I've got it cited here. Oh, right here. Okay, so he says, since on average, it will take this many generations for such mutations to reach fixation, about the same number of neutral mutations should be fixed every generation. The rate of fixation of mutations is theoretically constant and equals the neutral mutation rate. This is the theoretical basis of the molecular clock. And so basically, it sounds counterintuitive, but
What is the name of it, though?
This is just from an introductory level textbook titled Evolution. Christopher Roop owns the textbook, and so he was able to derive the quote. You'd have to look at it online or download it. But here we explain his formula. This is because the fixation of effectively neutral mutations via genetic drift is the underlying cause of the mutational paradox. You'd have to read through this. But basically, your neutral mutation rate, let's say it's 0.5, over enough time equals the fixation rate. Because you have so many mutations in a population. Yes, many are lost, many are drifting, but enough are being fixed that it equals the per generation rate. And so I just recommend reading this article I put out. Go ahead. Yeah, take your time.
So, right, when we measure deep time mutations, we are measuring the fixation rate because we don't know what other mutations are being lost. Is that what you mean?
No, what I mean is whatever your per generation rate is, so let's say it's 0.5, your fixation rate, as in how many of these new mutations are being stuck in place, they're being fixed in the population, it's the same over enough time. That's the way it works out. If the neutral mutation rate is 0.5, the fixation rate is also 0.5.
But that's not what it says there. That says that neutral mutation is the underlying cause of the mutational load paradox.
No, it says that right here, the rate of fixation of mutations is theoretically constant and equals the neutral mutation rate. So he's saying for mutations to reach fixation, about the same number of neutral mutations should be fixed every generation. Because again, you have mutations that have been accumulating for many, many years. In deep time evolution, it's even more years, hundreds of thousands of years. And so, yeah, you have a lot of mutations in this population. And so many are just drifting. They're not being fixed.
But
many are being lost, but enough are being fixed over time that your per generation rate is the same as your fixation rate. So if it's 0.5 per generation, the neutral mutation rate, 0.5 is being fixed.
So the neutral mutation rate is a small fraction of the actual mutation rate. So yeah, that makes sense.
So if the neutral
total mutation rate is a lot larger than the neutral mutation rate.
Well, right here. So if the effectively neutral mutation rate is 50 per person per generation, then that means 50 nearly neutral mutations will become fixed every generation. So whatever the neutral mutation rate is, that's also how many are becoming fixed every generation.
Yeah, that's much different than just the total mutation rate.
Well, did
we lose Beamsy?
It's a complicated issue, the population genetics point. So we probably lose a lot of the audience on that. Yeah. Feel free to read that technical article Chris Roop and I put out. It's sound. We had Dr. John.
If you link it, I can get it.
Okay, here, let me do it.
And then I was looking for that. I saw Beamsy said, I don't know. I thought this was an open room, but I don't know why he didn't pipe up. He linked something useful. There's variation between Y chromosomes in Australian and European peoples is 5%. So
I clicked that paper. I'll have to read through it. But I want to say this for the audience, for those on the panel. A lot of this is technical, but I think this also is analogous to the Y chromosome. Okay, the Y chromosome, the question is, why are Y chromosomes so dissimilar? The separate ancestry proponent like myself or Sam, we would argue the reason why they're so different is because there exists separate ancestries. Humans and chimpanzees actually don't go back to a common ancestor 6 million years ago. When it comes to the Y chromosome and mitochondrial DNA data, let's say mitochondrial DNA, the reason why there's such low variation, a fast mutation rate, is because humans only go back a couple hundred generations and ultimately about 6,000 years to mitochondrial Eve, the mother of us all. And so from there, her mitochondrial DNA was passed on, mutations have accumulated, formed new branches on the tree. We can back those branches up, back up to the woman of whom we've all descended from, right? And so it's very parsimonious. But I think you guys, Taylor, you have to invoke genetic drift, population bottlenecks, purifying selection, slower mutation rates in the past. It seems like you guys are kind of on the defense on the issue. Well, I know you disagree.
Well,
Go ahead.
all of that's been discovered and demonstrated to exist. But I'm getting a privacy error on your link here. It says you may be trying to steal my credit card information. Is that me? Is that just
Is it really?
Yeah, that was
do I
me.
just have my
I need some money.
do I have my firewall on too high a setting or something?
Sam's trying to get you.
I just
Sam,
need $20, you know.
in that link I just
Joke's
posted
on
to
you.
the side.
I only trade in crypto and gold.
Oh man. So then you don't even have $20 anymore.
I tried to figure out how to get some crypto.
Yeah.
Just can't devote enough time to it.
Sam, you're tricky. You're sneaky. Sam, any points you wanted to make or add as we kind of start to wind things
No,
down?
I mean that was a good back and forth from both of you guys. So yeah. That's it.
Taylor, anything you
All right. Well, thanks for. I like these open mics. So yeah, I try and catch them. I finally caught one this time. So
good.
Taylor, before you leave, please, I finally found this paper I was looking for. You and me are similar. We have 1,000 slides. It's hard to find sometimes the exact paper. So look at this one. This is from Nucleic Acids Research, Eve consensus sequence. And so they looked at 16,569 nucleotides. They found that 84% of the mitochondrial genome is invariant. But here is where you can see what I'm saying. So in this paper, they point out that on average, the mitochondrial DNA differed from, so any person basically on the planet in their mitochondrial DNA differed from the consensus by only about 21 nucleotides, which is pretty. I mean, that's barely anything. I'd argue that doesn't take very long to accumulate, and I would argue that that's biblical time. And so have a look at that. What they did is analogous to if I handed out 100 books, okay, and told you to copy the 100 books to 100 different people, and each person has to copy the book. Well, each person is going to have their own mistakes. And so if I wanted to derive the original book that I handed out without mistakes, I can examine all 100 books and I can see where the mistakes are. You can take out the mistakes and then you can come basically derive the original book again. And so that's what they did with mitochondrial DNA. They were able to find the variable places, the invariant places, and discovered an Eve consensus sequence. We'd argue that this is Eve's legit mitochondrial DNA sequence. You guys would argue this is a coalesce sequence that probably goes back 100 to 200,000 years. But speak to that if you'd like to before you go. And also, I just recommend checking out that paper.
Well, yeah, I mean, to use your analogy, it would be each person deviates from the original copy a little bit, but each person's copy of that copy might be very different. So that's the difference between, the difference between actual people groups like the Europeans and the Australians, and the difference between those groups and their common ancestor. So they're gonna be more different from each other than they were from the common ancestor.
Well, as mutations accumulate, right, there is going to be divergence, especially more divergence in people groups that are isolated, like Australian Aboriginals, or, if a group in China is isolated from a group in America for hundreds of years, they're both accumulating their own specific mutations, and so they're drifting apart more and more.
So it seems like you should be able to grab any one of those people groups and extrapolate back to that same consensus if we all derived from that same consensus, right? So that would be
Sure.
like a prediction that creation could make.
Gentlemen, I think we're coming on 3.5 hours. I feel bad because the Centurion, you joined, brother. George Bond joined earlier. He didn't get a chance to speak. I apologize. Once we get into that final hour and a half, Sam, it kind of becomes a free-for-all, doesn't it?
It does.
Actually, the whole thing's kind of a free-for-all, but this has
Kinda
been a
was.
fun night. Great discussion. I'm glad Taylor joined.
Yeah.
Taylor's always fun to talk to because he has a good working knowledge on these topics, and so we can get technical. We've had a great show tonight. Nathan, Centurion, Professing Preterist. Gentlemen, if there's anything you guys wanted to say or add or give your feedback before we wrap things up, go ahead.
Yeah. Donnie and Sam, great to see you. Just real quick, did the pseudo Dr. Dino show a picture? Because I was driving home and he looked like he showed a picture that had intestinal organs and stuff like that of his little dinosaurs running around. It was,
I remember him showing pictures of Tyrannus and what he claimed were associated feathers or proto feathers. And then he showed different structures. I think he showed the feet to try and show similarities. I can't remember all the details though. Snake, you unmuted if you wanted to go and elaborate.
Well, no, I don't know what you're referring to, but I was just going to say I'm going to hop off so I don't so my lady doesn't chop my head off. So
yeah,
but,
I think me and Sam were in the same boat. So yeah, my pleasure. Feel free to join next time, Taylor. We'll set you up for some debate. So appreciate the discussion.
Yeah, sorry we kind of hogged the mic, but I'll try and make it to the next one so you guys can talk to me as well.
Cool.
All right. See ya.
Snake,
have a good night.
Have a good night.
Yep.
yeah,
Or you
because
can
I was just
email me and I'll we'll set something up anytime. So
cool.
All right. Bye. Dog bless.